How's it going, guys? In this video we're going to be talking about how do contactless flow sensors work. And if you are running some kind of chemical process, you've already built an entire setup, you've got plumbing everywhere, so you're going to have pipes. And if you wanted to be able to know what the flow rate was inside of one of those pipes, it's going to really suck if you have to cut this pipe, shut down your process, put in a mechanical flow sensor, weld up these seams you now have in your pipes, bring this system back up, go through a whole startup procedure. And so it's a very expensive and time-consuming process. So if we have some way of not needing to ever cut the pipe in the first place and just being able to bolt on some flow sensors onto your system, this is a very attractive option for a lot of people. And so the way that these things work is they send ultrasonic signals through the pipe and through the actual fluid that's flowing through the pipe. And depending on how quickly, or depending on the volumetric flow rate of the fluid moving through this pipe, the amount of time that that ultrasonic signal takes to make its way through the pipe will vary. And so this means that we're able to draw correlations between the volumetric flow rates and how long it takes for a signal to move from one point, bounce off the inner pipe diameter, and then be reflected and received by some kind of transmitter on another side of the sensor. And by charting all this out, we're able to figure out what kind of flow rates we have for fluids inside of a pipe. Now, one of the issues here with the contactless flow sensors is that temperature perturbations or temperature gradients inside of the pipe, as well as the actual media, do make a very big difference on how quickly the ultrasonic pulse moves through the pipe as well as the fluid inside of the pipe. And so there are some workarounds for this that people are using in industry. One of these is to basically use both the receiver transmitter on both sides of your sensor and send two signals, basically signal one from one receiver transmitter to another receiver transmitter, and then a fixed time period later send another signal from the other receiver transmitter back to the original receiver transmitter. And by doing this, and by knowing that there had to be some kind of constant time value, because we already knew the time difference between when these two signals were sent, we were able to help better control for these types of temperature perturbations. That being said, contactless flow sensors do have somewhat narrow operating temperature limits. We're only able to go from about 0 degrees C to 85 degrees C, but for most purposes this is probably more than adequate to help people get a lot more insight into the kind of flow rates that are happening inside their chemical processes. And so that is going to wrap things up for this video. I hope you guys find it useful. Let me know if you guys have any questions, and thank you all for watching.